So welcome back. Today we'll be completing the second part of the chapter industrial design. So we understood that industrial design, this kind of learning are more important for industry people or researchers from engineers or researchers who are working in a company. Maybe not too much for academic people, but depending on the kind of work we academician might do in our lab, it is very diverse. mm, so depending on that, maybe this kind of topic is also can become important, because if you are working on some device which is like a prototype of something, a product which is a user driven product, so there is always a angle of industrial design comes into the picture, that you need to understand at least what is the basics of industrial design, and if not making a full-fledged commercial product out of it, but at least you deliver that thing in its core. It has essential features that will make it successful when a certain company will take that idea and make it a successful product and all this thing. And sometimes our projects are also funded by industry, so they want things in a certain way. And so again, I'm saying that that most of the cases academic people, we work on very much specific core technology, or not even core, but some sort of a technology driven thing. So for example, I work on, simply speaking, building a machine which performs certain kind of very technical tasks. So there industrial design may not be that much important. So but it is good to know these concepts. That's what I'm saying. So let's get started then. Okay, so first, so last week we learned a lot of things, and basically uh, first part of the chapter, and we understood a lot of concepts. But this week we will start with asking very simple question that what is the different kind of cost structure to performing in proper industrial design for your potential product actually. So that to understand that, so you have to understand it has three category of cost. I mean, you can divide this your expenditure into three categories: direct, manufacturing cost, and of course the time cost. That's also not like a from an exact money point of view, I mean indirect money point of view. So yeah, so maybe I'll just give you a context. I'll just read it from the book. Managers will often want to know, for a specific product or for a business operation in general, how much effort should we invest in industrial design. While it is difficult to answer this question precisely, we can offer several insights by considering cost and benefits. The cost of industrial design include direct cost, manufacturing cost, and time cost. Now, direct cost is the cost of industrial design services that you are taking from by hiring some professionals. This quantity, this quantity is determined by the number and type of designers used, duration of the project, and number of models required, plus material cost and other related expenses. So so what happens is that a lot of corporations, small companies, they hire industrial designer, not like they don't have a permanent industrial designer working in their company, because it's not needed actually. So they hire them, and they sometimes they give them money per hour basis, and depending on what kind of iteration that you want, and various and kind of project requirements, the cost can be very much different. So that's the direct cost. Now, manufacturing cost is the expense incurred in implement the product details created through industrial design. So for example, surface finishes, stylized shapes, rich colors, and many other design details. So this can increase tooling cost and or production cost. So that also needed to be understood, like it's an ID or industrial design cost actually, uh, because you incorporated these features, which are maybe from an function of the product point of view not needed, like certain colors and all these things, but you incorporated it under by understanding this process, that okay, so these aesthetics are important, ergonomics of course is very much important, and so that cost also have to be taken inside the the cost of industrial design. And finally, time cost is penalty associated with extended lead time. As the industrial designer attempt to refine the ergonomics and aesthetics of the product, multiple design iteration and or prototypes will be necessary. This may result in delay of in the products sorry products introduction, which will likely to have economic costs. So we all know that in various kind of businesses there are a lot of competition. So and introducing a right kind of product at right time is very important. For example, in my field, I know that there are a lot of different kind of therapy, specific kind of alpha therapy based cancer treatments are now become very popular. So from a physicist or mathematician point of view, researcher's point of view, I want to work on certain thing where I want to build a machine that can serve the purpose of this future need of this kind of research by people. So for me, the customer is actually again the researchers, maybe from medical or biological or chemical background. So there comes that cost of time actually, because I have to deliver this thing maybe in near future. I mean, if really I want to make a profit out of it, I mean profit in a sense, like again in a very inclusive way, like building a good CV and all this thing also comes into the picture. So anyway, so these are the three types of cost. Now yeah, now we'll understand what is the structured way of doing industrial design. So many large companies have internal industrial design departments. Small companies tend to use contract industrial designers design services provided by consulting firms. In either case, the industrial designers should participate fully on cross-functional product development teams. Within these teams, engineers will generally follow a process to generate and evaluate concepts from technical features of a product. In a similar manner, most industrial designers follow a process for designing the aesthetics and the ergonomics of a product. Although this approach may vary depending on the firm and the nature of the project, industrial designers also generate multiple concepts and then work with engineer to narrow this option down through a series of evaluation steps. Specifically, the industrial process can be thought of as consisting of following phases. So here you can see the 6 phases. So the first step is the investigation of customer needs. So that in the book there is chapter 5. It's called identifying the customer needs. So the product development team begins by documenting customer needs, and that is described in chapter 5. Because industrial designers are skilled at recognizing issues involving user interactions, industrial design involvement is crucial in the need process. I mean, in this particular process, they should be part of it. For example, in researching customer need for a new medical instrument, the team would study an operating room, interview physicians, and conduct focus groups. While involvement of marketing, engineering, and industrial design certainly lead to a common, comprehensive understanding of a customer needs for the whole team, it particularly allows the industrial designer to gain an intimate understanding of the interactions between the user and the product. So here we understood that how even of course, since we are part of this whole lecture series, so you all know in back in long ago in the lecture series we understood that the what are the product development steps, concept generation, system level design, etc., etc. So what here author is saying that the industrial design, depending on the product, it can be in the initial phase also, so you need to hire those people and to integrate those people into your main core product development team, and it should be done from the start. So that's the thing that author is saying here. Second step is conceptualization. Once the customer needs and the constraints are understood, the industrial designers help the team conceptualize the product. During the concept generation stage, engineers naturally focus their attention upon finding solution to the technical sub-function of the product. So engineers task would be, for example, let's say trimmer. So the basic technology of the trimmer is not like an across different all the different, I mean, if you search in any Amazon, or in case of India, if you search in Flipkart, this kind of website, you will find trimmer, man's trimmer category. There are a lot of different companies and different kind of products, but the point being that the inside the technology is same actually, almost. It's not too much difference, but still there's too many products, and that's because the industrial design, how it is been performed and all this thing. So when a certain company is making a trimmer, so their core engineering and scientist team would be more focused into the various sub function of it, and how they will whether they will bring a new kind of technology, different kind of blade material, etc. So their task will be more focused, but the industrial designer would be more of an their task would be how to make all these things, given these sub functions, merge them together in a way. Now here also comes the communication between industrial designer and the core engineering team becomes important, because various things cannot be I mean, you can't just put various sub functions randomly, there is a certain geometry had to be followed. But on top of that, then industrial designer will have, okay, so I'll create this kind of thing so that it is hard to easy to hold. That means from an ergonomic point of view it's better. So all these things comes to the picture. So at this time, the industrial designer concentrate upon creating products, form and user interface. Industrial designer makes simple sketches known as thumbnail sketches of each concept. These sketches are a fast and inexpensive medium for expressing ideas and evaluating possibilities. So here in the figure, in the leftmost figure, you can see these are called the thumbnail sketches. It is unfortunate that in some companies, industrial designers work quite independently from engineering. When this happens, ID is likely to propose concept involving strictly form and style. There are usually numerous iterations when engineering finds the concepts technically infeasible. Firms have therefore found it beneficial to tightly coordinate the effort of industrial designers and engineers throughout the concept development phase, so that this iteration can be accomplished more quickly, even in sketch form. So one thing we need to understand, that industrial design is not a full-fledged engineering degree or engineering. They are not called full-fledged engineers, although we know from our previous week's video, that kind of training the industrial designer goes through is like they get some art and also all basic knowledge of engineering. They do have that actually, and which is needed actually. Now third is preliminary refinement. In the preliminary refinement phase, industrial designer build models of most promising concept. Soft models are typically made in full scale using foam or foam core board. They are second fastest method, only slightly slower than sketches used to evaluate concept. Although generally quite rough, these models are invaluable because they allow the development team to express and visualize product concepts in 3 dimensions. Concepts are evaluated by industrial designer, engineers, marketing personnel, and potential customers through the process of touching, feeling, and modifying the models. Typically, designers will build as many models as possible depending on time and financial constraints. Concepts that are particularly difficult to visualize require more models than do simpler ones. Fourth step is further refinement and final concept selection. In this stage, industrial designer often switch from soft model and sketches to hard models and information-intensive drawing known as rendering. Rendering show the detail of the design and often depict the product in use. Drawn in 2 or 3 dimensions, they convey a great deal of information about the product. Rendering are often used for color studies and other testing for testing customers' reception to the proposed product's feature and functionality. So in here in I mean, yeah, in the, I think leftmost figure is also called rendering. Yeah, I think the right the I mean the leftmost figures right portion, I think that is the rendering figures, I think, most probably. I'm not really sure about that. Yeah, the final refinement step before selecting a concept is to create a hard model. These hard models are still technically non-functional, yet are close replicas of the final design with a very realistic look and feel. They are made from wood, dense foam, plastic, and or metal, are painted and textured, and have some working features such as buttons that push or sliders that move. Because a hard model can cost thousands of dollars, a product development team usually has the budget to make only a few. Yeah. So here in the in I think the middle sorry, the right figure, top right figure, you can see this is actually shows a hard model built by Google's Project Era to refine their concept for a new modular mobile phone. Yeah, so you can see it's basically you can detach a lot of functional part of it, and I don't exactly know. Yeah, but you can see that physically or maybe ergonomically, when certain people will touch it, it will feel like a real product. Something like, although functional, there is no functional component into it. And yeah, the fifth step is control drawing or model. The industrial designer complete their development process by making control drawings or control models of the final concept. Control drawing or models document functionality, feature, sizes, color, surface finishes, and key dimensions. Although they are not detailed part drawings known as engineering drawing, they can be used to fabricate final design models and the other prototype. Typically, these drawings or models are given to the engineering team for detailed design of the parts. Yeah. So this is the figure, next figure, and the left bottom left figure. And sixth step is final step is the coordination with engineering, manufacturing, and external vendors. The industrial designers must continue to work closely with engineering and manufacturing personnel throughout the subsequent product development process. Some industrial design consulting firms offer quite comprehensive product development services, including detailed engineering design and the selection and management of outside vendors of material, tooling, components, and assembly services. And as far as the drawing is concerned, specifically the fifth step, one can use again the CAD the computer aided design software. And technically you can see, um, yeah, so the particular example author had taken for this chapter, that is the Motorola's Razr phone, and that in the rightmost bottom right figure you can see this is the CAD image of that, and I think this is a control drawing most probably. Let me see. Oh no, that's not control design, but anyway, so just I'm saying that you can use the CAD in a much more sophisticated way. I think the previous drawings that in the I mean this figure that you see, that's more like a geometric and all this thing. But I think nowadays people use CAD for a lot of purposes, so I think all this can be done in CAD. So yeah. Now the question is, how do you manage? I think the better way to propose this question is that, um, what kind of product needs what kind of design, ID or industrial design involvement. So there you have to understand that depending on the, if it is a technology driven product, then it doesn't need too much, or it needs different kind of industrial design involvement. But if it is a user driven product, then it needs a lot of involvements from the industrial designers. So the primary characteristic of technology driven product is that its core benefit is based on its technology or its ability to accomplish a specific technical task. While such a product may have important aesthetic or ergonomic requirements, consumers will most likely purchase the product primarily for its technical performance. For example, a hard disk drive for a computer is largely technology driven. It follows that for the development team of a technology driven product, the engineering and technical requirement will be paramount and will dominate the development efforts. Accordingly, the role of industrial design is often limited to packaging the core technology. This entails determining the product's external appearance and ensuring that the product communicates its technological capabilities and modes of interaction to the user. User-driven product. The core benefit of a user-driven product is derived from the functionality of its interface and or its aesthetic appeal. Typically, there is a high degree of user interaction of these products. Accordingly, the user interfaces must be safe, easy to use, and easy to maintain. The product's external appearance is often important to differentiate the product and to create pride of ownership. For example, in office chair is largely user driven. While these products may be technically sophisticated, the technology does not differentiate the product. Thus, for the product development team, the industrial design consideration will be more important than the technical requirement. The role of engineering may still be important to determine any technical feature of the product. However, because the technology is often already established, the development team focuses on the user aspect of the product. So in the figure you can see, it classifies a variety of familiar products. Rarely does a product belong to one or two extremes. Instead, most products fall somewhere along the continuum. These classifications can be dynamic. For example, when a company develops a product based on a new core technology, a company is often interested in bringing the product to the market as quickly as possible, because little emphasis is placed on how the product looks or is used. The initial role of industrial design is small. However, as competitors enter the market, the product may need to compete more along user or aesthetic dimension. The product's original classification shifts, and industrial design assumes an extremely important role in development process. One classic example is the Apple MacBook laptop computer. The core benefit of the first Apple laptop was its technology, a highly portable computer using the Macintosh operating system. As competition entered the market, however, Apple relied heavily on the industrial design to create aesthetic appeal and enhanced utility, adding to technical advantage of the subsequent models. So yeah, so the last topic that we'll discuss is the timing of the industrial design, when it will start in the whole product development process. Mm, so typically, industrial design is incorporated into the product development process during the later phases of a technology driven product and throughout the entire product development process for a user driven product. So here you can see in the figure, this illustrates these timing differences. Note that the industrial design process is a sub process of the product development process. It is parallel but not separate. As shown in this figure, the industrial design process described above may be rapid relative to overall development process. The technical nature of the problems that confront engineers in their design activity typically demands substantially more development effort than do the issue considered by industrial design. Yeah, and in this figure you can see that for a technology driven product, industrial design activities may begin fairly late in the program. This is because industrial design for such product is focused primarily on packaging issues. For a user driven product, industrial design is involved much more fully. In fact, industrial design process may dominate the overall product development process for many user driven products. Yeah. So here, depending on the product, that means whether it is a technology driven or user driven product, you can see the industrial design team when and each I mean in different steps of product development, starting from the identification of customer needs to the detailed design, testing and refinement. You can see what are the tasks of the industrial designers. So for technology driven product, in the phases of identification of customer need, there is no involvement from the industrial designers. But for user driven product, industrial designer works closely with marketing to identify customer needs. Industrial designers participate in focus groups or one-to-one customer interviews. In the second step of product development, which is called concept generation and selection, the industrial designer, in case of a technology driven product, works with marketing and engineering to ensure that human factors and user interface issues are addressed safely, and maintenance issues are often of primary importance. So a lot of times, specifically for technology driven product, it can be very costly product, so it's not like some trimmer. People just it's not working, after 2 years they throw it out, throw this and buy it again, not like that. So maintenance is important. So, and also maintenance also, I think industrial designer have to understand the maintenance part of it. And I think last week we discussed that maintenance is a very important issue. So they have to design various sub module of the system in such a way that certain part can be detached easily, etc. Okay, so now for the same phase of concept generation and selection, the industrial designer for user driven product generates multiple concepts according to the industrial design process flow described earlier. In the third stage of concept testing, the industrial designer helps engineering to create prototype which are shown to consumer for feedback. So this is for technology driven product. For user driven product, industrial design leads in the creation of models to be tested with customer by marketing. Similarly, in the fourth step of system level design, industrial designer for technology driven product typically has little involvement, and for user driven product, industrial designer narrows down the concept and refine the most promising approach. Finally, for detailed design, testing and refinement, industrial designer for technology driven product is responsible for packaging the product. Once most of the engineering details have been addressed. Industrial designer receives product specifications and constraint from engineering and marketing. And for product user-driven product, industrial designer selects the final concept, then coordinates with engineering, manufacturing, and marketing to finalize the design. So that's it all about the this, and this will be the so that's it all about the industrial design chapter. Hope you like, and yeah. Okay, so as usual, this is the book we follow for this generating the content, and this is the download link you can use. And that's it all about the video. See you in the next week.